Hello everyone, in this video we're going to solve this equation which contains rational expressions. As usual with such equations, we need to first find any value of the variable k, which would make either of these two denominators 0 and exclude that from the list of possible solutions. So we can see here that if we simply set 3k minus 12 equal to 0 and solve it, we would quickly find k equals 4, which would be the only value of k that would make either of these two denominators 0, so we exclude that. So the list of our restrictions includes the fact that k should not equal to 4. And we're going to check for that as soon as we find some proposed solutions. And also we need the LCD because that's the most efficient way of handling equations like this containing rational expressions. We clear the fractions by multiplying both sides by the LCD. We can see the LCD here is simple. It is simply quantity 3k minus 12 squared. So we're going to be multiplying that LCD on both sides of this equation. So we'll multiply it on the left side. And of course we have to distribute it. So let's go ahead and do that. So we'll just multiply it by 2, and we'll also multiply it by the second term. And we also, of course, need to multiply that on the right side, because whatever we do to one side of an equation, we have to do to both sides. All right. So now we notice that here we have a complete cancellation of the 3k minus 12 squares on the right side. On the left side, in the second term, 3k minus 12 factor cancels one of the ones on the top, so it just leaves one factor of 3k minus 12. So once we clean it up, we have 2 times 3k minus 12 squared plus 5 times 3k minus 12 equals -2. Now we could solve this equation by squaring this expression here and then simplifying, etc. But there's a cleverer way of handling it, and that's using a proper substitution. We notice that we have what's called quadratic form. Anytime you have a constant times some variable expression squared plus another constant times the same variable expression plus a last constant equals 0, we consider this to be quadratic form. So of course we have that here. We have notice that this variable expression is the same as this variable expression. Here it's being squared, here it's not, and then we have a constant, so we are in quadratic form. Of course we can always move the -2 to the other side. So the way that we'll handle this is in fact using a substitution. We'll go ahead and let u be 3k minus 12. So this means, of course, that u squared is going to be 3k minus 12 squared, quantity 3k minus 12 squared. So now we substitute wherever we see 3k minus 12, we'll substitute u for it. So we end up with 2u squared plus 5u, and we'll go ahead and bring the -2 over to the left side, so we get plus 2 equals 0. Notice that complicated looking thing became a really nice simple quadratic equation right here using that substitution. So now we'll go ahead and solve this quadratic in U for U. So let's see if we can factor it. Looks like it shouldn't be too difficult. Looks like 2u here, maybe a 2 here, and a u here, and a 1 here should do. And I think there'll be pluses all around. So let's make sure first times first is first, last times last is last. The outer product is 4u, the inner product is u. They add up to 5u, so we have the correct factorization. So now we go ahead and apply the zero factor property, which tells us either 2u plus 1 must be 0 or u plus 2 must be 0. So here we end up with 2u equals negative 1/2. Actually, let's try negative 1 first. 2u equals negative 1. I jump one step ahead, so we get u equals negative 1/2. And on the right side, we have u equals negative 2. Of course, we don't stop here because we haven't solved the original equation for k. We've solved a modified equation for u. So now we need to substitute back in for u. So we know that, let's go ahead and put those up here. U equals negative 1/2 and u equals negative 2. Recall that u is 3k minus 12. So now we're going to substitute 3k minus 12 for u. We get equals negative 1/2. Once again, we have an equation containing fractions. We'll clear the fraction by multiplying both sides by the LCD, which is simply 2. So we'll go ahead and multiply each of these terms by 2 because of distribution. And of course, we don't forget the right side. So we end up with 6k minus 24 equals negative 1. So 6k equals negative 1 plus 24. So 6k equals 23. So we get k equals 23 over 6. That's one solution. Now we will go ahead and do a restriction check on that. That means we make sure that it doesn't violate what shouldn't happen, that it's not equal to 4. And of course, that is not 4. It's close to 4, but it's not 4. So we're okay. Now we'll go ahead and do the same thing on the right side with u equals negative 2. We'll substitute 3k minus 12 for u, so we get 3k minus 12 equals negative 2. And now we get 3k equals negative 2 plus 12, so 3k equals 10, and that gives us k equals 10 over 3. We also need to do a restriction check on that, and we notice that 10 over 3 also is not equal to 4, so that passes as well. So they both pass the restriction check. And of course, if you have extra time, you can always plug into the original equation to make sure it's okay. And we'll leave that for you. But the very least amount of checking that needs to be done with such a problem is the restriction check. So that's the very least you should do. So if we write the solution set, we're going to have two items in it. One is 23 over 6, the other one being 10 over 3. And that's how you can handle a relatively complex problem like this using a nice substitution of this variety. And that should do it for this problem. So stay safe till our next video.